Hello, and welcome to our channel, a nexus for the inquisitive and perpetually curious. Today we're jumping into a kind of cosmic detective story. We'll be delving into a really mysterious object, something right at the edge of how we think planets actually form, our focus. A fascinating and pretty heavily debated celestial body. It's known as HD 100546b. This audio overview is based on a post originally published on the Perpetually Curious Facebook page.
That's right. And this isn't, just any old exoplanet candidate. We're talking about something potentially huge, a candidate gas giant, maybe. And it's surrounded by its own disk of gas and dust. It's like a unique window, a live view into how planets are literally put together, a snapshot of creation happening. And what's really got scientists talking is the debate about what it actually is.
Okay, so our mission for this deep dive is to look closely at the sources, exploring its origins, its, strange features, and the big questions scientists are asking about it. Let's start unpacking this. So, to kick things off, where is this HD 100546b? What's its cosmic neighborhood like?
Right location. Well, based on the latest Gaia DR3 data, which is incredibly precise stuff, it's about 359 light years away from us. It's tucked away in the constellation Musca, the southern fly.
Okay, 359 light years. And the star it orbits?
Yes, the host star, HD 100546. It's a young star, a Herbig AB type, very massive, very luminous. And young means maybe only 5 to 10 million years old. And the key thing here is it's still wrapped in this huge protoplanetary disk, gas and dust. Basically the leftover material from its own birth. It's the perfect environment, really, a messy, active place for planets to be forming. It's exactly the kind of cosmic cradle we want to study. This is where it gets really interesting.
A cosmic cradle, I like that. Okay, so this chaotic nursery. Let's zoom in on HD 100546b itself. What do we know about its size, its structure, mass? Given how young and, messy everything is, I imagine getting solid numbers is tough.
It is incredibly tough. The figures we have are, let's say, preliminary. Very tentative. Infrared observations hint at a possibility. It might have this enormous circumplanetary envelope with a giant gas cloud wrapped around it, maybe up to 6.9 times Jupiter's radius.
6.9 times Jupiter. Wow.
Yeah, but that's the envelope. The core inside, the more solid part perhaps, might be closer to, say, 3.4 times Jupiter's radius. Still big, but maybe not that big at the core.
Okay, so size is uncertain. What about mass? That seems even more fundamental.
The mass estimates, they are all over the map. Seriously. Some studies suggest maybe 1.65 times Jupiter's mass. Others go up to a massive 25 times Jupiter.
25. That's well into brown dwarf territory, isn't it?
Exactly. That huge range isn't just measurement error. It tells us something profound is going on. It might mean we're seeing something so young, so dynamic, that's very nature, planet, or brown dwarf, or maybe something else, is still being well defined. It really pushes how we even classify these things.
That uncertainty is really something. If the mass is that debatable, how sure can we be about anything else? Like its orbit, how far out is it? How long does a year take there?
That's a fair point about confidence. It's all part of the ongoing investigation, We know it orbits its star pretty far out, about 53 astronomical units, plus or minus 2 AU.
Okay, 53 AU. Remind us, an AU is the Earth-Sun distance. Right?
That's right, about 93 million miles, or 150 million kilometers. So HD 100546b is orbiting 53 times farther from its star than we are from the sun. It's way out there.
Way out there indeed. And its orbital period. How long does it take to go around?
The estimate is around 250 years for one orbit. But again, there's significant uncertainty. The whole system is young. It's dynamic. Things might still be settling. Calculating a precise, stable orbit is, it's tricky. Like you said, trying to track something that's still moving around a lot.
Okay, so this brings us right to the heart of the mystery, doesn't it? What is HD 100546b? A planet? A brown dwarf? Or maybe just some kind of knot or feature in that huge disk? This is where the debate really kicks in.
Precisely. And there are different camps. Some researchers look at the emissions we detect and suggest, maybe this isn't a distinct object at all. Maybe what we're seeing is actually coming from complex structures within the disk itself, a clump, a spiral arm density wave, something like that.
So it could be an illusion almost, or part of the disk structure?
It's a possibility. It's incredibly hard to tell apart a very young planet still gathering material from the dense active disk it's born from. Imagine trying to spot a specific swirl forming inside a thick, moving fog.
Right. And I read there might be another object complicating things.
Yes, to add another layer here, there's talk of a potential HD 100546c, another candidate object further out. It's unconfirmed currently, but if it exists, its gravity could be stirring things up, maybe explaining some of the weird structures we see in the disk.
Which would then impact how we interpret the signals from object B. Okay, it's a complex dance.
It really is. A whole system shaping itself.
Now, shifting from structure to substance, what about the chemistry? Have we found anything unusual in the composition of this cosmic lab?
Oh, yes. Something really stands out. The disk around HD 100546. It's missing a lot of sulfur.
Missing sulfur. How much are we talking?
A lot. Roughly 1,000 times less sulfur than our models predict should be there based on typical interstellar abundances. It's a huge depletion. Really makes you scratch your head.
1,000 times less. Wow. What does that imply?
Well, it's a big chemical fingerprint. It tells us some unique chemical processes must be happening there. Maybe sulfur is getting locked up in certain minerals very efficiently, or maybe it's being processed in unexpected ways. This affects the overall chemistry of the disk, obviously, and that means any planets forming there might end up with very different atmospheric compositions than we'd otherwise expect.
So it forces us to broaden our ideas about what kinds of planets can form.
Exactly. It helps refine our models of planet formation, showing just how diverse and complex the chemistry can be right from the start. It highlights the sheer variety out there.
This episode is brought to you by the Perpetually Curious, a platform for the inquisitive and ever curious. So how are we getting these amazing details, seeing chemical fingerprints 359 light years away? That requires some serious hardware, right?
Absolutely. A real game changer here has been ALMA, the Atacama Large Millimeter Submillimeter Array. It's this incredible network of telescopes high up in the Atacama Desert in Chile. Think of it as a giant, super sharp eye looking at cold gas and dust.
And what has ALMA shown us in this system?
It's given us these incredibly high-resolution images of the protoplanetary disk around HD 100546. We can actually see fine details, things like spiral arms winding through the disk, distinct gaps where planets might be clearing paths, asymmetries, features that scream dynamic processes happening now.
Like watching the construction site in action?
Pretty much. And ALMA doesn't just take pictures. It can detect the specific signatures of different elements and molecules. That's how we get insights into the chemical composition, like that sulfur puzzle, and the physical structure of the disk. It's crucial for figuring out the mechanics of planet formation.
ALMA sounds incredible. Have its observations thrown up any big surprises that maybe challenge older ideas about disks, or is it mostly filling in the details? And looking forward, what's next? How can we get closer to solving the HD 100546b mystery?
Oh, ALMA constantly reveals complexities. It shows us these disks are rarely simple, smooth structures. They're lumpy, asymmetric, definitely refining our models. The universe is always more intricate, right? As for what's next, a lot of hope rests on the James Webb Space Telescope, JWST.
Webb, of course.
Upcoming observations planned with Webb. They could be transformative. Its infrared capabilities are just phenomenal. It might give us the data needed to really pin down the nature of HD 100546b. Is it truly a self-contained planet, a brown dwarf? Or is it fundamentally part of the disk? JWST has the best shot right now at answering that.
So, potentially a definitive answer soon.
Potentially.
Yeah.
But we should be cautious too. Even with Webb's power, interpreting the data from such a complex embedded object might still be ambiguous. It might take more observations, more modeling. It really underscores that science is a process, an ongoing discovery. Each new piece helps, but the full picture can take time.
Okay, so stepping back a bit. For you, the listener, the perpetually curious learner, why does wrestling with this distant debated object, HD 100546b, actually matter? What's the takeaway?
That's a great question. For you, the curious learner, thinking about HD 100546b isn't just about some faraway speck. It's like looking through a cosmic time machine, understanding its chaotic birth, the debates around it. It gives us this almost live view of what our own solar system might have looked like billions of years ago. Planet formation isn't neat and tidy. It's messy, violent, dynamic, uncertain. Seeing that process unfold, even with all the questions, helps us appreciate the incredible journey that led to Earth.
It connects us to our own origins in a way.
Absolutely. It broadens our understanding of planetary nurseries and the sheer diversity of ways worlds can come into being. It's a key piece in understanding the cosmic lottery that resulted in us being here.
To explore more topics like this, follow the Perpetually Curious on Facebook. So thinking about all these challenges, the debates, the uncertainties surrounding HD 100546b, what do you find is the most, maybe surprising thing about trying to understand planets forming in these earliest, most chaotic stages?
The most surprising aspect. For me, I think it's the sheer fact that planets do form amidst all that chaos. You have this incredibly energetic star, powerful winds, radiation, gravitational stirring, yet somehow dust grains stick together, grow into pebbles, then planetesimals, then full-blown planets. It's like cosmic resilience. Matter finding ways to aggregate and build complex structures despite the intense environment. It's a testament to the fundamental laws of physics, I suppose, but it still feels kind of amazing every time we see hints of it happening. It constantly pushes us to rethink how worlds, including our own, actually came to be. The universe always seems ready with another puzzle.
Thank you for watching. Visit the Perpetually Curious on Facebook and YouTube for more related content. Share this journey with fellow explorers, and if you enjoyed the video, please support us by subscribing, sharing, liking, and turning on notifications.
Thank you for watching. We invite you to explore our channel, where you will find captivating content across a wide range of topics, from everyday wonders to engaging subjects like science, arts, nature, history, technology, and more. If you enjoyed this episode, we would sincerely appreciate your support. Please consider liking, sharing, subscribing, and turning on the bell for notifications. For those wishing to support us further, you may consider one of the following options. By tapping the Super Thanks button on YouTube, or through Buy Me a Coffee using the link in the description, or by scanning the QR code shown on screen. Your support is truly appreciated. Thank you. Before you go, take a moment to explore the related content here. You might just find your next favorite video. Thank you for watching.